when given y equals x to the power of n, if you differentiate it, it will give you this. And in the previous video, we've seen that by using the natural log, this thing here works even in the case of n being an irrational number. So in the previous video, we would put something complicated into the n, like minus pi, and it still led us to this. You see, by you using the natural log, you can actually, this thing here will still work. Okay, so in the general case, if you have y equals x to the power of n, if you start out as this here, take the natural log of both sides, that will then give you this. So basically, in the previous video, we did it in the case of y equals x to the power of minus pi. I wanted you to see that even though you put an irrational number or complicated irrational number into this thing here, it still works. So in this video, we're going to do it for the general case. So it will be for any n. Okay. So given this here, if you take the natural log of both sides, that will then give you this, and then use implicit differentiation. So because y here is a function of x, just remember that when you differentiate the natural log of y, it will give you this. But because y is a function of x, you've got to times it by dy by dx. Differentiate this. So at the moment is this thing here. Don't forget n is a constant. N is a constant. It doesn't change, whereas this one here will change. Well, anyway, if you differentiate this, it will give you n times 1 over x. Okay, and then now try to isolate dy by dx. So times both sides by y. So that will give you this times this. And don't forget y. Don't forget y is x to the power of n. So you can put x to the power of n into this y here. So that will then give you this. Okay, and then what? Oh yeah, and then from here you can see that imagine this as being x to the power of 1 here. Okay, imagine this as being x to the power of 1. So really, whenever you have x to the power of a divided by x to the power of b, it's basically this take away this. So it's really this take away this. So that then gives you that would then give you n and then x n minus 1. Okay, so dy by dx equals this. So it works in all cases. Okay.